Biomimicry can be applied to almost any field in human society. And that's really the beautiful thing about biomimicry is that it is so relevant to almost every industry. So we have examples of biomimicry in transportation, like you mentioned about the bullet train being made more aerodynamic by emulating the bird's beak and the other aspects of the owl, etc., to make it quieter.
Biomimicry can be useful to save a lot of time in innovation. It's about designing and innovating with nature. We talk with biomimicry expert Ayla Kiser. She has multiple years practicing biomimicry principles and has recently founded her own company. This is the Gen Z in STEM podcast. I'm your host, Maidrin, and I hope you're as excited as I am. Let's get to it. All right, well, welcome. So today we're going to be talking about biomimicry. So first of all, you have years of expertise in biomimicry and have an engineering and environmental scientist background. Additionally, you're one of the first biomimicry practitioners to be hired by a multinational corporation to work on biomimic consumer products. And I've recently founded Luminous Biomimicry, which aids train individuals on the subject and provide consultancy for companies. So yeah, first of all, can you maybe tell us a bit about yourself and who you are?
Sure. So my name is Ayla Kiser. I'm originally from the United States, but I crossed over the ocean and I'm now living in France. And yeah, as you mentioned, I have a background in engineering, starting with mechanical engineering, and then I got my master's and PhD in environmental engineering. And somewhere along that point during my studies as an engineer, I heard of this thing called biomimicry. And as soon as I heard about it, my heart started beating a little bit faster. And it just made so much sense to me that I wanted to really learn more about biomimicry, and that's what I did. So after getting my PhD, I was working as a postdoctoral scientist at a research institute, and I had the chance to join a biomimicry Master of Science program. And so I did, and it was a very good decision that I made in my life. I'm so glad I did that, and I studied biomimicry, and now this is the path that I'm on.
Okay. And we said biomimicry 6 times, but maybe there's a viewer out there that doesn't know what biomimicry is yet. So let's get right into that. So what is biomimicry and how would you define it?
Yeah. And I want to say, if you don't know what biomimicry is out there, whoever's listening, don't feel bad because it's a term that a lot of people still don't know about. And yet that's part of the work that I want to do. I want more and more people to know what biomimicry is. And I have a lot of colleagues in the field of biomimicry who are doing the same. So what is it? Before I get into the formal definition, I'll give just a bit of context. Essentially, we're surrounded by around 9 million species, and some scientists will say, oh, there are trillions when you factor in bacteria, archaea. So let's say we're surrounded by trillions of species. And every single species, including ourselves as humans, we need to survive in the environment that we live in. So all species have strategies to survive in their environment. And there are strategies that are common across all or most species, and there are strategies or mechanisms that are unique to a particular species. And so we can learn from both our own bodies, but all other species as well, about how to live and function in a way that is both effective, we get what we need to do done, but that's also sustainable. And so biomimicry is essentially solving our human technological and environmental challenges by learning from nature and emulating the strategies for success that is found in nature in all species, all biological species.
Yeah. And yeah, I think that's super important because I think also when we were discussing in the past, together, we tend to innovate and we talk about innovation and, advancing our society. but we sometimes forget to like look around us for those ideas and for this innovation.
Exactly. Yeah, and that's what makes biomimicry so powerful. Uh, the problems that we're trying to solve today, the solutions already exist in nature because life has been on Earth for 3.8 billion years, according to scientists. So that's a very long time. And human technologies are very recent. I mean, you could say that our modern technologies really took off during the Industrial Revolution, say in the 1700s. So what we're doing, what we're producing, the way we're functioning in the modern world is very new compared to the R&D that's been done in nature for the past 3.8 billion years. So with biomimicry, instead of trying to solve a problem by just looking at what other people have done and trying to make incremental changes or improvements, or trying to solve a problem from scratch, starting from zero, we can kind of cheat, if you will, or jump to the answer quickly to whatever problem we're trying to solve by looking at nature, how nature has already solved that problem. So it's a way of saving time, saving energy, um, but it also helps us to think outside of the box of human thinking. So it's really a way of expanding the solution space. Of course, we have to look at what other people have done up until this point to make improvements or develop something new. But wow, what if we can also look at what nature has done and bring nature to the design table? To me, that's the ultimate way of problem solving.
Yeah, honestly, I would agree. And there's some really cool examples I think you'll go into a little later on, and I've seen some of my own. But in general, like, why is biomimicry like so relevant also for like innovators and like scientists in our world?
Well, I think more than ever, we need technology that's both innovative and effective, but also sustainable. And in nature, nature is simultaneously very productive and innovative, and it also functions in a way that is good for all species for the long term. And humans have been extremely, I mean, we're very intelligent. We've created amazing technologies already. The problem is that some of those technologies were created in ways that didn't consider the effects of those technologies or the way that they're made on other species, on or ourselves. And so they're not necessarily sustainable. And we're seeing that today where, when we turn on the news, we hear about this number of hurricanes that have hit, this part of the world, and just climate change and pollution and loss of biodiversity. I mean, we're facing huge challenges that have been caused by us, the way we've done things up until now. So
Mhm.
biomimicry gives scientists and innovators the opportunity to solve problems effectively and innovatively while also not causing more problems in the future, especially for the environment.
Yeah, yeah, and I think that's super important when you say like because climate change and like biodiversity loss is actually something like current, very relevant that is impacting other aspects and other things. And
Yeah.
like you said, if we maybe like look at what nature's already doing, also in like a chemical like level too, because for instance, materials we source, they're having like damages on our environment. So if we like actually look at these, yeah, if we source it directly from like nature and apply this to an innovation, maybe it will be more ethical and help us like innovate in a more sustainable way. Totally
Yeah.
agree with that.
So we can use natural materials in a bio-inspired way, or we can actually emulate nature's chemistry um, in laboratories using biotechnologies. And so, like, one example is that, well, right now there's a huge problem with what are called forever chemicals, PFAS. They're per or polyfluoroalkyl substances. And these substances have been used mainly in consumer products to repel water, to keep stains off of fabrics, and repel grease. Unfortunately, though, it turns out, and actually scientists in some companies knew this for quite some time, but it only more recently came out into the open, these chemicals are toxic at very low concentrations, at concentrations of parts per quadrillion. So that's like picograms per liter. We see toxic effects. And just to give you a scale of how low that concentration is to see toxic effects on other species, it's like the area of a footprint within all of North America. Obviously, the units are different. I mean, concentration
Yeah.
picograms per liter, but just to give an idea of how low that concentration is to have a toxic effect. And unfortunately, scientists have been finding PFAS in breast milk, in the blood that in the umbilical cord that feeds babies or fetuses,
Yeah.
and it's just found in most compartments of the environment because it unfortunately it moves very easily and rapidly through the environment, and it takes for some of these PFAS chemicals over 1,000 years to degrade. So they're very resistant to degradation, and that's why they're called forever chemicals. So this is a big problem because they're everywhere. Now, the good news is that we don't have to keep using these types of chemicals. There are alternatives and bio-inspired alternatives. So, for example, there is the pitcher plant, Nepenthes. It's a type of carnivorous plant, and you can imagine the shape of a pitcher, like a water pitcher. And these plants, they emit a really nice odor that attracts ants. But these plants, they have a particular surface structure on their outer edge where ants can climb up and walk around. It's a micro scale surface structure that when it gets wet, like when it rains, a film of layer gets trapped within this microstructure, a film of water, and it forms like kind of almost like a trapped layer that lubricates the surface of the pitcher plant, and it makes it really slippery. So it'll emit this odor, especially I think after it rains. And so the surface is nice and slippery. Ants will come crawling up onto the plant thinking they're going to find some really good food. And the ants will slip into this pitcher, which has some digestive juices, and the plant digests the ants and eats them. Great strategy, like really, really innovative. And poor ants, but it's the cycle of life. And so scientists have been inspired by this. At first the question was, wow, what makes the surface so slippery? And especially ants. Ants are known for being able to walk on walls upside down. I mean, they're really good at adhering to surfaces, but not the pitcher plant. So they studied the surface structure and how that fluid water gets trapped in that surface structure, and they were able to emulate that. And so there's a couple of companies that have created and have on the market products that were inspired by the pitcher plant. So there's one, it's called Spotless Materials is the company. And this is actually for consumers. You can go online and buy it today. It's like a spray that you can use in the house or for your car. And one of their products is like a spray for toilets. You can spray the inside of the toilet bowl, and it creates this coating that is inspired by the pitcher plant that prevents waste and other nasties from sticking to the surface of the bowl. So it's almost like kind of self-cleaning. It's very easy to clean because everything just slides right off, just like sliding off a pitcher plant. And there's another company, Adaptive Surface Technologies, that has done the same thing, and they're using this for consumer packaging to make packaging such that even really sticky substances like honey can't adhere to the walls of the packaging. And so when you're trying to get that last drop of honey or ketchup out of the bottle, like a standard bottle, and you're trying to wrestle with it, but with this pitcher plant inspired coating, it comes right out. So there's less waste, and easier to clean surfaces, and it's not using these forever chemicals.
Yeah, I love these examples because like those are examples I had actually never heard of. Because when you think of like biomimicry, at least there's some that have been a tiny bit in the news. such as like, for instance, the bullet trains that used like different type of birds and like penguins like beaks to like kind of get, more aerodynamic train.
Yeah.
Um, and
Or
then there
the
was also another one that was. Then there was another one that's very common from Janine Bissus. I don't know if I'm pronouncing it exactly well, but you might know this book. It's like one of the biomimicry books
oh yeah.
where they kind of looked at like spider silk and how like that could be used to like replace, for instance, like steels, because it was also very strong when you looked at the chemical properties and stuff like that.
Yeah.
But I want to know a bit about like your career, because you actually like were on a like research and development team at Johnson and Johnson's for 5 years, and you
Cool.
had to apply biomimicry principles.
Hmm.
So I was wondering, in your work, like what like sort of principles did you ever use, and like what were some applications?
Yeah, so I essentially used what's called the biomimicry thinking process as I was taught through the program that I got my master's degree, which is from the United States at Arizona State University through Biomimicry 3.8, which is it's this kind of the sister organization to the Biomimicry Institute, which was founded by Janine Benyus and Dana Baumeister. And so through my education there, I learned how to do biomimicry, essentially, how to apply the the steps of solving a problem by seeking inspiration from nature. And I was hired to use biomimicry to create new design concepts or new solution concepts for consumer products at Johnson and Johnson. And I should specify that Johnson and Johnson has three different divisions, or at that time it had three different divisions: pharmaceuticals, medical devices, and consumer products. And I was working in the consumer products division, although biomimicry could have very well been used in pharmaceuticals and medical devices, but I was hired in the consumer product section. And since I worked at J&J since I left, the consumer products division has actually separated from J&J, and it's a different company now. But anyway, so I was hired to innovate new consumer products or to improve existing ones. So I started off applying biomimicry in that way, but then I couldn't help myself. I got in touch with the sustainability team at Johnson and Johnson Consumer Health. And I reached out to them and started interacting with them because I felt like biomimicry can also inform the sustainability policy or framework of the company. So I started getting involved with that as well. And I also started working with the packaging team towards more sustainable packaging. And so essentially, I mean, the general steps of doing biomimicry, a lot of it is the same as any design process, where first you have to really understand what the problem is. And I always treat a problem like a system. What are all of the contextual elements of the system, both physical, like, okay, temperature, pressure, different forces that are acting within the system where the problem exists, and also economical. What are some economical constraints? What is the budget of the company? How much money will they put into this product? What are our manufacturing capabilities? And also the culture of the people who will be using those products. What do they like? What do they not like? Etc. So I mean, there's a very rich context that we need to understand in order to successfully solve a problem. So we understand all of that, understand the causes of the problem, what are the main factors causing the problem that we're trying to solve. And by understanding that context, then we can figure out what functions we need to achieve in order to solve the problem. So for example, I worked on, and I can't go into too much detail, unfortunately, about what I worked on because of confidentiality. But I can tell you in general terms, I worked on a project where I was asked to find a bio-inspired way to protect the skin from irritants, and in particular, irritating fluids in the environment. So I studied the context of that problem and the way those irritating fluids could interact with the skin and cause problems. And then I brainstormed, and I should say we brainstormed because I was working with an intern at that time. Together we brainstormed different ways to stop those factors that were causing the irritation from happening, or to block the interaction of that irritating fluid with the skin. So, or reduce. I mean, there's a lot of different ways that you can think. So we could repel the fluid from the surface of the skin. We could absorb the fluid away from the skin. We could help the skin have a stronger barrier, or develop its barrier against irritating fluids in a more significant way. So there were different ways. And then we chose, for example, to repel fluids from the surface of the skin. So then we asked the question, well, how does nature repel fluids from biological surfaces? And once you have that question, the function that you're trying to achieve, repelling fluids from a surface, then you can start doing research. How does nature repel fluids from the surface of the skin? And that's when you see all kinds of amazing ways that other species, or even our own body, it could be, that our own bodies or other species repel fluids from surfaces. So that's really the key step in biomimicry, is thinking about the solution to a problem in terms of functions. Like, what do we really want to do? What do we need to do in order to solve this problem? Are we repelling fluids? Are we attaching to a surface? Are we sending signals? Are we receiving signals? So, are we filtering particles? You name it. I mean, there's a million different functions that we can be interested in, and it's very likely that those functions are found in nature. So, for example, another example, you know, biomimicry helps us to think less about what the solution should be, um, and think more about function. So we may start off with an idea like, oh, we want to make a better light bulb, for example. And so, we could change the filament material, we could change some geometry or what have you of the light bulb. But then if you want to solve the problem in a biomimetic way, you would say, okay, this is what humans have done. So you have to do that research. You have to understand how humans have solved this problem and how people have tried to make improvements. But then you can ask, like, well, what function does a light bulb need to accomplish? It needs to illuminate. It needs to illuminate a dark space. So, or yeah, illuminate some space. So then you can ask the question, well, how does nature illuminate? And then you start finding organisms that are capable of illuminating, generating light, like fireflies, for example, or bioluminescent bacteria in the oceans. And you find out, oh, they have a different way of creating light than our light bulbs. So that's just an example, but right away you see, oh, there's a different way of solving this that we wouldn't have thought of if we hadn't looked at how nature does it.
I love that because it's like it is a really like structured process, but then you nearly add like an extra step by looking at like how is it done in the world. You
Exactly.
look at these functions, then apply it to what are you doing.
Yeah, how does nature do this? And then once you find species that are doing the same thing that we need to do, that we want to do, then we study how those species accomplish that function, and we emulate to the best of our abilities what that species does. We kind of translate or abstract those biological mechanisms into design principles that we can then incorporate into our solution.
Yeah. Mhm. And so you were also mentioning a lot of examples at the start about like this plant that had like, well, I guess that was slippery, I guess, then it was used for like packaging and different applications. So you've seen a lot of like applications through your time at working with like biomimicry. But I'm wondering, so in your experience, which industries have really, for instance, like used biomimicry, and which are maybe like lacking and need to maybe adopt these practices or could benefit from adopting these practices?
Say that almost almost all, I think there are examples of biomimicry in almost all industries. And if there aren't, there absolutely can be or will be, because biomimicry can be applied to almost any field in human society. And that's really the beautiful thing about biomimicry, is that it is so relevant to almost every industry. So we have examples of biomimicry in transportation, like you mentioned about the bullet train being made more aerodynamic um, by emulating the bird's beak, and the other aspects, the owl, etc., to make it quieter. Um, and there's other examples too. In fact, I was just at an additive manufacturing conference a couple of weeks ago, and it was fantastic. And I gave a keynote talk about biomimicry for additive manufacturing. And at this conference or summit was the world's fastest bike. And it turns out the world's fastest bike is bio-inspired, and it emulates the tubercles that are found on the fins of humpback whales. So if you look at these humpback whales, you'll see at their fins they have bumps on the front end or edge of their tubercles, and that helps them to maneuver in a very agile way. It helps them to make turns really quickly. And scientists suspect that these tubercles, they add lift to the whale and also reduce drag.
Mhm.
And so this bike, it applied the same concept on the front, and I'm not sure of the right bike terminology, but there's the vertical bar where the seat is on that goes down, and they put similar ridges or bumps on the front of that. And apparently it significantly reduces drag on the bike. And that single bar accounts for about 40% of the drag on the bike. So by emulating the humpback whale's tubercles on that front side of the bike, it significantly reduces the drag and it goes faster. Of course, there are other aspects of the bike that make it the world's fastest bike, but biomimicry plays a role in that. So that's pretty cool. So transportation, I mean, there's so many examples. It's hard to to. We have examples of biomimicry in architecture, energy, health, even beauty, cosmetics.
Mhm.
It's across the board. And now there are even people who are working on biomimicry for social innovation,
Mhm.
uh, that I think is really interesting. Because humans, I mean, we form, I mean, we are a society, and our businesses, for example, function like systems. Our businesses are a form of systems. And we can learn from natural ecosystems about what makes those ecosystems um, more resilient, more sustainable, the principles of resilience and sustainability in natural ecosystems, and we can apply those same
Yeah.
principles to our human social systems, for example.
Yeah. So then my question now would be like, well, since it can be applied everywhere and in pretty much every field, so why would it be important to have more individuals trained in biomimicry? And then what benefits would that bring to like society, which is kind of what you are sort of doing with like Luminous or aim to do.
Yeah, I think it's so important that as many people as possible know what biomimicry is and
Mhm.
know how to use it. Because if we have one day companies where people who work in those companies, people who are experts in a particular field, if they have biomimicry as a tool in their problem-solving toolbox, they'll be able to find, they'll be able to see different ways of solving problems that they may not have been able to see on their own. And that was my experience at J&J. I
Mhm.
worked at J&J with just within J&J, I was able to work with people in skincare, in baby care, oral health, over-the-counter medications, packaging. And every time I worked with a team, I saw, what they had done before to solve a particular challenge. And when we brought biomimicry into the problem solving, the the way of solving the problem, we were able to look at the problem differently and find different ways of solving the problem. And the creativity just went like through the roof. I mean,
Mhm.
it was so powerful to see how biomimicry could help us find different and very unique, better ways of solving certain problems. Um, so I think if more people had this as a tool, we could solve problems more innovatively, potentially faster, because again, it's not having to reinvent the wheel.
Yeah.
And again, most importantly, more sustainably. And the sustainability piece is something that I think we really need to focus a lot more on with biomimicry. And that's something that I want to do with Luminous biomimicry. I mean, for me, innovation and sustainability cannot be separated. And in nature, they're not two different things. So companies don't have to choose between being innovative and profitable or sustainable. They can be both at the same time. And so if people
Yeah.
have
Mhm.
the tool of biomimicry and the knowledge of how to use this tool, then I think it would be a game changer. I think we would um, solve our problems, including the big one of how are we going to live on this planet in a way that is healthy for the long term.
Yeah, definitely. And yeah, I think you've mentioned like lots of like very important like pieces, but maybe that has led you to create like Luminous biomimicry. So then my next question is actually like, well, what led you to create Luminous biomimicry, and what like do you bring to like the biomimicry space?
So what led me to create Luminous biomimicry was first this conviction that biomimicry is absolutely necessary today and in the future to solve our ground challenges. Um, I just think it's essential. It's essential for our future. It's not the only tool that we need to
Mhm.
use to solve these grand global challenges. And it doesn't even have to be for solving grand global challenges. I mean, it can be used to solve any sort of problem. So I think it's essential. So that's why I want to work in this field because I believe it is essential now and in the future. And then the second thing is that when I teach biomimicry to university students. And when I teach this to university students, I see how their eyes light up. I mean, it's almost like I can see it in their faces. The
Mhm.
the the wow factor is always there every single course. And I always ask for feedback at the end of the course, of each course. And every single time the students say, "This is amazing. Why haven't we learned about this before? I want to do this." And usually I'll have a line of students after the course asking me, "Is there an internship? Like, where can I start working on in biomimicry work?" So, I mean, that has been so motivating to me to see these students because they get it. I think young people, Gen Z, and I think the younger ones are, oh, I said, yeah, Zoomers? Or is that the same thing? Gen
I
Z and
think
Zoomers?
so. There's Gen Z. After it's like a generation Alpha, they go back
Okay.
to Z, so A. And
Okay.
before, I think it's millennials. Yeah,
Okay. I'm I'm already like outside of all of that, but I think young people generally young people get it. It's very intuitive. But I mean, people of all ages get it. When I give seminars about biomimicry to seasoned professionals, the reaction is almost always the same. wow, this is so inspiring. How, we need to learn more. How can we do this? So that's why I created Luminous, because it's essential. Biomimicry is essential. It inspires people. It gives people hope because the solutions already exist to our problems. Just acknowledging that is so comforting. We don't have to, in panic mode, scratch our heads and say, how are we going to figure this out? How are we going to get ourselves out of this mess? The solutions already exist. We're surrounded by them in the form of millions of species. And so biomimicry is a very hopeful, uplifting field. And finally, just in my own personal experience, when I started studying biomimicry as a student, I felt, and this is going to sound maybe kind of corny, but I felt deep joy just learning about nature and doing some exercises where I had to go outside and observe a tree or, look around me at nature, even in my local park. Just doing that really opened something up inside of me and made me feel deep joy and a greater sense of connection to nature and the earth. I felt more human, so to speak. So all of these benefits and the benefits that I experienced at J&J, and the learnings that I got from working at J&J, what it means to apply biomimicry in real time in an actual company, inside of a company, I learned a lot from that experience. Things that we can't even learn at school or that I didn't learn in school, I learned by actually applying it in a real world setting. So all of these benefits of biomimicry, I want to share with as many people as I possibly can. So that's why I created it. Yeah,
Yeah, yeah, and that it's like all out there. That is super hopeful. Like just look around and embrace it, and there are solutions. But yeah,
exactly.
and then my last question is, so what hopes do you have for like the use of biomimicry worldwide, and how do you hope it like evolves globally?
Yeah. I really hope that more and more people are going to learn what biomimicry means. They're going to see its potential, and we're going to start applying it. I mean, in my dreams, biomimicry will be a part of schools. It'll be a part of school curriculum or
Hmm.
curricula, so that students at young ages they start at least with the basic concept of look at nature. Nature is amazing. It's not just a source of materials for us to
Hmm.
take or dominate. It's a source of wisdom and guidance, and it's a source of health and well-being. I mean, there's so much that we get from nature. And so if school children can be taught this, that's already that would be amazing. And then
Hmm.
in high school, universities being taught how to use biomimicry as a problem-solving tool, that's that's in my dream of seeing that one day. And then of course,
Hmm.
companies uh, to have this as part of their DNA for problem solving, that would be a dream come true. If every company in the world will one day use biomimicry as part of their problem solving, that would be amazing.
Hmm. Ultimately, it would benefit them. Like you'd have
Yeah,
to have the upfront investment, but then when you do it, you find new solutions and ways of doing things. So.
yeah. So I said every company. Obviously, that's a bit of an exaggeration. If we can just get to a tipping point where enough companies are using it to have an impact, that would be incredible. I just saw recently on a website, there's a company called Blue Planet Systems, and they were inspired by coral reefs and the way rocks are formed in nature. Um, and essentially a lot of organisms in nature or species, they will take carbon dioxide out of the air or out of water, and they use it as a source of like a feedstock. They use it as a raw material to create sugars or some other product that they need. And so there are companies that have been inspired by this process of taking CO2 out of the air and then using that CO2 as a raw material to create some kind of product. In Balloon Planet Systems, they're making concrete by emulating the way corals and take CO2 out of the air and create their structures. And so what I read on their website is that if 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 we replace just 16% of all aggregate, like concrete aggregate that's used today, we would be able to, by 2050, pull enough CO2 out of the air to keep temperature rise below 1.5 degrees centigrade. So just 16%, if we made this change from standard aggregate to bio-inspired aggregate for building, it would have a huge impact. So that's kind of like a tipping point. Can we get to the point where 16% of our concrete aggregate is bio-inspired? Ideally, it would be even more than that. But even that would make a huge difference. So in every industry, we can apply biomimicry and get massive benefits for both ourselves, for our society and the way we live our lives, but also for the rest of the planet.
Yeah, I think those are great final words. And I would just add to that, as also a student myself who first learned about this in high school, was just, yeah, go read a book about biomimicry. There are many out there for all levels. Go search about biomimicry, because really it's a powerful like tool that we need to apply more.
Yeah,
But yeah.
that's great that you heard about it in high school. Bravo to your teacher, whoever introduced it to you.
Yeah. But yeah, so thank you so much for like coming on and sharing about biomimicry. I'll be sure to link the resources you said in
Oh,
the episode
sure.
notes.
Thank you so much, Maya. And if, your listeners have any other questions or are interested in something in particular, they can reach out to me through my website or on LinkedIn.
Great. Yeah, it's appreciated. I'll also link it. But yeah.
Okay.
Thank you for listening. If you enjoyed the episode, please share it with friends and family and consider giving us a follow or rating on your favorite platform. We'll be back soon to bring more inspiration to your Monday.